All right, let's talk about something that probably made a lot of us groan in school. Fractions. Yeah, I know. For so many of us, they were just a total headache. But what if I told you that the story behind fractions is actually, well, it's incredible. It's full of ancient puzzles, weird history, and even some pretty cool brain science. So today, yeah, we're going to unpack that whole story.
So let's just dive right in with the big question. Why? Why does this seemingly simple idea of a part of a whole cause so much anxiety? I mean, if you've ever felt that frustration, you are definitely not alone. It turns out our struggle with fractions is part of a story that stretches back thousands and thousands of years. You see, here's the thing. A fraction isn't just a number. It's a relationship. It's the relationship between a part and the whole it comes from. And what's so fascinating is that humans have been wrestling with this exact concept for millennia, long before we had our neat little top and bottom notation. To really see just how differently you can think about this stuff, we're gonna go way back in time. I'm talking about the land of pyramids and pharaohs, ancient Egypt. So this incredible ancient document, the Rhind Papyrus from around 1600 BC, gives us our first real detailed look at how people used fractions. And it shows something that is just wild. The Egyptians did not think of a fraction like 2/5 the way we do at all. They had a completely different, and honestly, to our eyes, a very strange system. Their entire system, the whole thing, was built on one simple idea: the unit fraction. That's any fraction with a 1 on top, like 1/2, 1/3, 1/10. For the Egyptians, every other fraction had to be expressed as a sum of these simple unit fractions. And here's the kicker: no repeats allowed. Okay, so how in the world would they write something like 2/5? Well, the short answer is they couldn't, not like we do. Instead, they had to break it down into a sum of those unique parts. So 2/5 becomes 1/3 plus 1/15. I know, it looks so complicated to us, right? But for the Egyptians, this was totally logical. It was about seeing everything as a combination of these simple, distinct pieces. So how did we get from that really complex system to the simple numerator and denominator we all use today? Well, it was a long journey with a lot of help from different cultures all over the world. Turns out our modern fraction was a truly global invention built over centuries. Around 630 AD, the Indian mathematician Brahmagupta was placing one number over another, but with no line in between. Then, maybe 600 years later, around 1200, Arab mathematicians added that horizontal bar, a super simple but brilliant innovation. And finally, in the 1500s, Latin writers gave us the names we use today: numerator and denominator. So that whole history brings us to today. We've got this simple, elegant system for writing fractions. So why are they still such a huge stumbling block in school? Well, the answer has less to do with the math itself and a lot more to do with how our brains are wired. And this is not just a feeling, Researchers have known for decades that learning fractions is a, quote, serious obstacle for kids. That's from a landmark paper on the topic. It's a well-documented universal challenge. Okay, so here's the crucial point. Our brains love whole numbers. It's what we learn first. We count things: 1 apple, 2 apples, 3 apples. But a fraction, it isn't a thing. It's that relationship we talked about earlier. And probably the biggest mistake students make is treating the top and bottom numbers like they're two separate whole numbers instead of one single value. This slide shows that whole number thinking in action. Perfectly. A student is asked to add 1/4 and 2/4, and they see 4 separate numbers. So their brain just goes, hey, add the tops, add the bottoms, and boom, they get 3/8. They're applying whole number rules where they just don't belong. And the same mistake pops up all the time, even with different denominators. 2/5 plus 1/2 magically becomes 3/7. Again, the student is just adding straight across, treating all 4 of those numbers as totally separate items that just need to be combined. And wow, this brilliantly illustrates how deep the confusion can go. 4/6 minus 2/6 becomes 2/0. This answer just shows that the student isn't thinking about what a denominator even means. It's the name of the parts. That part shouldn't change when you add or subtract them. So just how common is this kind of thinking? Well, get ready for this. One study of 7th graders found that a staggering 66%, that's 2/3 of them, showed major, significant misconceptions, or really a complete lack of understanding when it came to adding and subtracting fractions. 2/3. That's not just a small problem, that is a massive hurdle in math education. Okay, so faced with this huge, widespread struggle, teachers are always looking for ways to make things easier. And this has led to the rise of all sorts of shortcuts and tricks. But do they actually help? Let's take a look at one of the most popular ones. It's called the butterfly method. Maybe you've seen it. It's this visual trick for adding fractions that lets you skip finding a common denominator. And it seems great. It's fast, it's easy, it's kind of fun. But the real question is, does it build real understanding, or does it just create a whole new set of problems later on? So let's compare. For a simple problem with just 2 fractions, hey, the method works fine. It's quick, it's easy. But what happens when a problem gets just a little more complex? When you have to add more fractions? The trick completely falls apart. You can't do them all at once. You have to add 2, get an answer, then add the next one to that, and so on. And the numbers, they just explode into these huge, unmanageable things. The easy trick suddenly becomes a total nightmare. And this whole situation perfectly illustrates a huge debate in math education today. It's this tension between knowing how to get an answer and really understanding why the method works in the first place. So on one side, you've got what's called procedural fluency. That's the how. It's all about memorizing steps and using tricks like the butterfly method. It can be fast for sure, but as we just saw, it's also really fragile. But on the other side, you have conceptual understanding. That's the why. This is about truly getting what a common denominator is and why you need one. And that kind of knowledge is flexible, it's powerful, and it can be applied to any problem no matter how complex it gets. So let's just recap this incredible journey for a second. The fraction started as an ancient puzzle. It evolved over centuries with help from people all over the world. Then it became this massive hurdle for our modern brains to get over, and now it's sitting right at the heart of a huge debate about the very soul of math education. Which really brings us to our final thought. The story of the fraction forces us to ask a really fundamental question about what we actually want from education. Is the goal just to get the right answer as quickly as possible, or is it to build a deep, flexible understanding that's actually going to last a lifetime? The path we choose there, well, it makes all the difference.